Hello everyone and welcome to our second video of the series discussing data analysis for water treatment and salination. In this video we are going to talk about how to use machine learning for water treatment and salination. So let's get started by importing the required libraries and modules. Then let's load our data and then let's take a look on our data. Suppose we have a data from a pilot plant or filtration system from water treatment application or desalination application. As you can see, we have like feed flow rate, feed TDS, feed salinity, and many other parameters, including pressure drop. As we discussed in the last video, our main objective is to figure out which parameter or set of parameters that affect pressure drop so that we can adjust those parameters by changing, for example, the operation conditions in order to decrease pressure drop in our system. Let's talk a little bit about machine learning, especially supervised machine learning. Suppose you have a data with different shapes and you wanted to make a machine learning model to predict the type of each shape. So you have a data or training data that it will be given to the model in order to get trained on those data in a simple way. Suppose you have a square and triangle and hexagon. So you will give the model those shapes and also you will tell the model what is the name of each shape. So you will tell it like this shape called triangle and this shape called square. So model now knows what is the type of each shape in your training data. Then it will create an equation that can describe the relationship between your labeled data or your shapes and its type. So after model training, you will have some data called test data that you are going to use in order to evaluate the prediction accuracy of your model. Suppose you have also a data with different shapes, then you will give it to the model without telling it the labels or the names of or types of those shapes. Then if the model was correct, it will give you the type of each shape in your test data. In this case, when we gave the model a triangle and square, it correctly differentiate between the both shapes and it gave square correctly as an square and triangle as triangle. So let's take our case as an example. For our case, our labeled data will be all parameters except pressure drop, and for sure the label will be the pressure drop. For example, we will give the model that at one point feed flow rate was 97.7 cubic meter per hour and salinity was 44.7 and temperature was 25 and like feed flow rate was 70 as a labeled data. And we will tell the model that at this point the pressure drop was 4.6, and we will do the same for all points in our training data. We will give the model all parameters at one point except pressure drop as a labeled data, and at this point we will tell the model that pressure drop was this number. So the model in this case will try to find an equation that describes the relationship between all parameters and pressure drop. Then after that, we will use our test data. For example, we will give the model a feed flow rate and feed TDS salinity and temperature and flow rate TDS recovery and flux. And if the model was succeeded in predicting the pressure drop, it will give us the correct pressure drop. For example, if we as a test data gives a model a feed flow rate as 80.82 and the salinity is 19.5 and temperature is 17 and for other parameters, if the model was succeeded in to find the relationship between parameters and pressure drop, the predicted pressure drop in this case will be 2.2 or around this number, so that then we can say that machine learning model was correctly predicting the pressure drop. Let's do it in Python in order to like explain it in a good way. So first of all, we will split our data into labeled data and labels. In this case, as we mentioned, we will say that X is all parameters except pressure drop as a labeled data, and Y will be only pressure drop or the label in this case. And as we mentioned also, we will split our data into training set that, that the model will get to in order to be trained, and test set that we will use to evaluate or to it will be used by the model to predict a pressure drop. Let's take a look about labeled data or all parameters as we mentioned except pressure drop, which is not here, and the label or Y will be only pressure drop column in this case. Then let's, as we mentioned, we will split our data into training set. Some data will be used by the model in order to get trained, and some data will be used to will give to model to predict our pressure drop, as you can see here. So part will be used here as training and part will be used as test data. Then we will train our model, which in this case called Random Forest Regressor. There are a lot of machine learning models, but in this case we will use Random Forest Regressor, and we will give the model X-train labeled data, all parameters except pressure drop, and pressure drop as a Y-train. Then after that, we will use the model in order to predict pressure drop, which in this case is called Y predict. So model will take X test all data except pressure drop in order to predict pressure drop. Let's run this cell also. So in order to see or to examine or evaluate our